problem here is that this is a warehouse floor, and all of these different things are like receptors. They say how far away the package is from each of them. So each one is a different distance. So to find it, we're going to make circles with our compass that are that far away and measured out, and that will show all of the packages that are that far away from it. And when we make all four of them, they will only go over one package, and that will be our answer. So to start out, node A, well, we'll start with node C because that's the shortest. Node C is 10.7 away. So we're going to take out our compass here and set it to 10.7 meters, which is about right there. Then we're going to put it right on the node and draw our circle. It's a little far away. There we go. So that is hitting this package, a little bit of this one, this one, this one, and this one. Now we will go to node B. That is 18.6 meters. So about right there. And draw our line. All right, now we've got two circles, so we've narrowed it down to these three packages here. Now here's where it gets a little tricky because compass can't set to 40.4 and 36.9. So what we're going to do is take this, and half of 36.9 is 18.45. So we're going to set it to 18.45, which is about right there. And then we're going to put it on node D and go straight out to here. So then this is where our compass is actually going to start. Then we're going to draw our circle. So the only package that all three is still going through is this one, but we're still going to do node A just to make sure. So 40.4, half of that, 20.2, which is about right there. So then again, we're going to put it here, go straight out, and that is where our compass is going to start. And it just barely nicks the corner, but it does make it. And now our actual questions are: the distances from each of the nodes to our particular package are shown on the floor plan below. Show where the package is located by circling the correct bin on the drawing. Well, this is the correct bin, so we're going to circle that, and part A is done. Part B is: explain how you determine the location of the package. What geometric objects did you use to make the model to model the possible locations of the package? What properties of those objects made them a good choice to use in this situation? We're going to write our answer down here so we have a little bit more room. So how we determine the location was by making a circle from each of the nodes. So we're going to write that down. All right. What geometric objects did you use to model the possible locations of the package? Well, we used circles. What properties of those objects made them a good choice to use in this situation? We used circles because the arc showed all possible packages. When we combine them, it showed only one bin. And now we have completed this problem.
And find out where the call is. So it says cell phone tracking technologies have been around for years. Law enforcement agencies use the technology to track and prosecute suspects, and emergency service providers use the technology to locate people who need help quickly. And it goes on, but really what we need to know is what we have to do. A. Explain how you can determine the boundaries of the region. What geometric objects or objects will you use to separate the part of the map where a cell phone caller is closest to Tower 2 from the regions where a caller is closest to another tower? What properties of those objects made them a good choice to use in this situation? B. On the map, use a straight edge and or compass to draw the boundaries of the region in which a cell phone caller is closer to Tower 2 than any of the other towers. Do not erase construction marks, lines or arcs that you use to construct the figure so that your method can be followed by someone familiar with geometry. So first we'll start with B. So we need to find the circumcenters to make 2 equal. So like find the region of 2. So we start off, we need to find the perpendicular bisector of 2, 1. So how you do that, so you place it on 1, about more than halfway, and you just draw a arc on both sides. And where they cross is going to be where you draw your line. So you take it, they crossed here and they crossed here. So you take your straight edge, make it straight line all the way. So then I need to find the perpendicular bisector of 2, 4. So I go more than halfway, so that's going to be a little bigger. It's about right there. You're going to draw, again, 2 arcs from that. Then go from 2, draw 2 more arcs from that point, and then you connect it. So from 2, 4, cross there, draw a line. Okay, so this is one circumcenter. And then you need to do 2 to 6. And so it's going to be a little bigger again. So take that, draw 2 more arcs. It's pretty much just repeating itself over and over again. You find out where they connect again, draw the straight line. Okay, so then I need to do 2, 3. So then I draw the same thing, make it a little bigger. Right there, like that. And then they connect right here. So then these 2 lines connect right here. So this line and this line connect here. Now that's it. Connect here, and then these 2 lines connect here, and then right here. So then you shade in that area, because this is region 2. So you shade in that area. So so the call inside of this is going to go through Tower 2. Inside in here. Okay, so then we'll go back to the front. Explain how you can determine the boundaries of the region. You're going to use perpendicular bisectors and you use the circumcenter of the perpendicular bisectors to find where the region ends. So you draw arcs so that you can construct. You draw the arcs to construct the perpendicular bisectors. And they were good because it showed multiple different, like these arcs showed it could be anywhere along there where the other arc crossed. But since it was only at this one, like here's a construction line. Here's the arcs. They only crossed here. So that's why we drew the line through it. If they could have crossed here, but you needed two of them because they were good to use. So they crossed where they were supposed to, and you drew a line through that dot.